Okay, so let me try to say what we are trying to achieve here, right? So you have the maze here starting, and then the agent has to go here and down and stuff. So what will happen is, so initially, it'll just keep getting the inputs. This is the input, this is the output. So let's just take it's taking some random action, and eventually, first the activations go like this, and goes here and eventually comes to left. So and then it keeps moving left, so it keeps moving left, and then it's coming here and it's getting stuck here in this corner. Okay, so what happens is the pathway just keeps getting stronger and stronger, whatever inputs is getting. So it keeps getting stronger and stronger, and what we are hoping will happen after like a 300 times or something is, this is already really strong, right? This path is already really strong. So just like, imagine a river or something that's flowing. So we're hoping that something like this would branch off the excess. There's already too much because the weightage is so high and the activation is so high. Almost everything along this path is almost one, let's say, weight. So because this is so, yeah, so I was saying, so this part becomes like really, heavy with the activation flow. And because of that, some of the other neurons, see, say for example, there's a neuron here with like really high activation and all that. So it is true that it is sending the activation this way, but also because it keeps on getting such a high activation, it starts to, because it's connected to five other neurons, right? So these neurons are along this pathway, but some of these neurons, this will start eventually, start getting a lot of activation, and the flow will start coming around this way. So, and along this way, it reaches down, eventually, like it takes a few hundred iterations or whatever, and then it reaches down. So and then, so at this position, this corresponding inputs, the agent moves down. Okay, so even now, the next time it comes to this particular position here, after it finishes the maze in the next lap or whatever, if it comes to this particular position, it is highly likely to take this path, but it also has a little bit of a chance to take this path. So the next time it comes to this position, for 100 time steps it will try to again fire this one, but and after that, maybe 101 or something, it will fire number 2, sorry, number yeah. So the 102nd time it will try to fire this particular neuron. So but after this thing keeps on happening repeatedly, this path will become as strong as this path, and at one stage this path will become more stronger than this path, because we are having a, let's just say, we are in the time step 101, right? And this is sometimes several lapses in the future where both this and this are of equal strength. So let's just say that for 10 time steps this path is getting fired, and then for the 11th and the 12th steps this path is getting fired, right? Or just say 11th. Okay, on the 11th time step this is getting fired. So what will happen is, at that particular point, the weightage of this path will be stronger, because there won't be any weight decay along this path, but there will be a weight decay here. So if the weightage between this and this is like point 1, like almost like the highest, let's say it's 1, right? 1 is the maximum weightage. So on the 11th time step, the weight decay will be there by like 10% or something, let's just say. So it will become point 0.9, but here on the 11th step this would be like intact, it will be like number 1, so full weight. So and then the subsequent time steps, they will both keep on decreasing by 10%, but it will still maintain the lead, because after the 11th time step, this is like at point. Yeah, so this thing maintains the lead. So this path will become the most likely path the next time this set of inputs are coming. So you're following it, right? Because even though initially it went to this path, uh, this becomes the path with the highest set of weights, because last time during the 11th time step, what happens is, it took the correct action and moved down. So and then we got a different set of inputs. So the last time we had this input corresponding to this position, the latest move was down, and that happens to be the correct move, right? And after that it changed position. So for this particular position, this pathway seems to be the most likely path that it would take the next time. So what happens is, in the future laps, it won't even have to wait 10 time steps for it to trigger the down rather than left. The minute it comes to here, it will automatically take downward action and not the left action. So like I said, initially it was taking some random step. After that it was just taking the left step for a long time. I know this is in the earlier laps, but after like 100 laps or something, after learning, what happens is, the minute it comes to this position, it correctly takes the correct output. So that's the learning.